Okay, welcome back. Now we're moving on to the last lesson for trigonometry, which is cosine law. Essentially, cosine law we're going to use anytime we have a acute triangle or a non-right angle triangle, and we can't have a matching side length and angle to be able to use sine law. We're always going to want to use sine law because it's easier than cosine law. So for cosine law, we have these two different formulas here for side length and for an angle. These formulas will be given to you. Now, these formulas don't really serve a purpose as far as the letters are concerned because the letters are always going to change. What has to happen here is that you have to understand what each of these letters mean and why we use them. So, to explain the first formula here, we're trying to solve for a side length. So the side length that we're trying to solve for is isolated. It's by itself. And the side length that we're trying to solve for here is A. So what we need to know is the angle that matches to A. The rest, this B and C and B and C, are the other sides. It doesn't matter that the order that you put these letters in. The only important thing that we need is that we need to solve for the side length and we need the angle that matches to the side length. I don't care about the angle for B. I don't care about the angle for C. I care about their side lengths, but I don't care about what their angles are because all I'm asked to solve for right now is the side length A, so I need its matching angle A. And then I can put in the other side lengths. The same is true as if you look at in reverse for the angle. So if I'm asked to solve for angle A, like here, I had angle A, so I used it in the formula, but now I need angle A. B and C, the other two sides, you're going to add them together and then you'll divide them. The only one that's special here is this subtraction. You see how these ones are being added together? Well, we need to subtract the matching side length to the angle that we have, or that we need to solve for, sorry. So that's understanding the formula. If we understand these formulas, then the letters don't matter, okay? So let's look at an example of finding an unknown side length. So this means I'm going to be using this formula here. So right now, it wants me to solve for B. So for here, in the formula, it wanted me to solve for A, correct? Well, now I need B. I really don't care, but you can write in the letter B squared, right? That's what you need. You could keep it as A squared. The letter doesn't really matter. What you need to know is that B and C are what in this equation? What are they? The other sides. They're the other sides. So now, do I have the other sides? Yeah, they're 36 and 52. So what do we do to those other sides? We square them and add them together. So let's do that. 36 squared plus 52 squared. Then what else do I have to do with this equation? Minus 2 times 36 times 52. Then what's at the end here? Cos A. Cos A doesn't mean I want angle A. That's not true. It's the angle that matches to the side length. So what's the angle that matches to the side length that you're trying to solve for here? 42. So then you'll write in cos 42. Now we'll solve. And the way that we're going to solve, I like to do it in two parts. You don't have to. You could type this in all into your calculator and press equal. It should be able to do it. But for me, I'm going to do 36 squared plus 52 squared is 4,000. So 4,000 minus 2 times 36 times cos 42. Don't be using inverse or anything like that. And we should get 2,782. So now when we subtract those two, 4,000 minus 2,782 is 1,218. Now, does that seem right? Can that side length actually be 1,218 if the other two sides are 52 and 36? No way. So what's going on here? Did I do something wrong? No, we've got a last step that we still haven't done yet. You want b, and right now you have b squared. So this is just like Pythagorean theory. How do you get rid of that square? You square root it. So the square root is 35. And it looks like it's been measured in feet, so we'll write 35 feet. So you see, cosine law is not actually that hard if you understand what those letters actually mean in the formula. So let's look at another example here. We're asked to solve for side length d. What's the angle that matches to d? 40. I don't care about angle E or angle F. The other side lengths are 20 and 40. So if we want side length d, we'll take the other two side lengths, square them, and add them together. We'll minus 2 times the other two side lengths, multiply it by cos of the angle that you're trying to solve for the side length for, which is at 40. We'll type that into our calculator. Again, if you want to separate them, go ahead. You can actually try to type it in all in once in your calculator and see if you get the same answer. So for me, I like to do it separate, like I said before. If you typed it in all into your calculator in one shot, you should get 194. If you can't, then keep it separated like I do. Do 10 squared plus 20 squared, which is 500. Do 2 times 10 times 20 times 40, which is 306. Subtract them. Then square root that 194, and you'll end up with the length being 14 meters. Okay, so that's how we're going to do side length. Those are our two examples for side length for cosine law. And now we're going to solve for an angle. So for our angle equation, let's go back and look at it. What's important to note is that if you're solving for angle A, you have to subtract angle A. Or sorry, side length A. The other two sides are the ones that you add and fill in the top and the bottom for the numerator and denominator. So let's see. I'm solving for C. So you know what I'm going to do? I'm going to circle that 14, the one that's across from it, because that's the special one in my equation. So when I go to fill in my equation, I need the angle, so cos C. Again, you could write cos A, you can write down the formula as it appears at the top, again, because those letters mean nothing. What are the other two sides that I'm not using? There's 17 and there's 16. So I'm going to add them together. The one that I subtract is the one that matches up to that cos C, which is the 14. What are the two sides that you put on the bottom? They're the other sides, the 17 and the 16. The only one that's special here is the one that matches up to the C, and it's the only one that you subtract. Now, when I do this, I want you to do the numerator and denominator separately because I've seen a lot of issues with this in the past. So on your calculator, let's just do 17 squared plus 16 squared minus 14 squared and press equal. You should get 349. Then let's do the denominator. 2 times 17 times 16 should get 554. Or sorry, 544. Now, when we're solving for an angle, anytime in trigonometry, this is our last time looking at this, but anytime we've ever solved for an angle, what have we always pressed? What's special about angles? Do we just use regular sine, cos, and tan? No, we use their inverse, right? So right now, we're going to use the inverse of cos, and this is going to be our numbers that we're going to type into our calculator. So let's press shift, cos, and then just like we did with SOHCAHTOA, we've got these two numbers for cosine that we're going to divide. So 349 divided by 554, so I keep saying 54, 544, put that in brackets, press equal, and you should get 50 degrees. Now, if you can't get that on your calculator, then this is what you're going to do. You have a one-line calculator. 349 divided by 544 equals 0.64. Second function cos 0.64, and you'll get 50 degrees. There's not a whole lot of work here with cosine law. It's just understanding how to use the formula. So let's see another example. D is what we're trying to solve for. Let's match it up. That means I'm solving for this cos D. The other two side lengths are 8.7 squared, 9.6 squared. We add them up. What's the side length that we subtract? The one that matches. Here we go. That's the one that I've subtracted. On the bottom, what are the side lengths that we write in? The other two sides. The first two sides that we wrote in, so the 8.7 and the 9.6. For me, I like to solve the numerator and denominator separately. So if I do the math for the top, I've got 121.61, and on the bottom, I've got 167.04. And try to keep all the decimals right now while you're still solving. Again, you can round at the end. Don't round ever in math when you're trying to solve. Only round when you have your final solution, okay? So try to hold on to as many numbers as possible during your steps. So now we'll press second function cos, bracket 121.61 divided by 167.04, and you should end up with a side length for D that is, an angle for D, that's what we're solving for, angle D of 43 degrees. Now again, we're worried about overall expectations that we're trying to cover because of COVID here and this new online learning that we're doing. So this word problem at the bottom here, question number 5, something that we don't have to worry about, but we do have to know how to draw a triangle and be able to solve using our trigonometric ratios, primary trigonometric ratios, sine law and cosine law. So for these ones, 3 and 4, I want you to read the questions right now, pause the video, and then draw the two triangles for both 3 and 4. Okay, you should have your two triangles drawn in. If I look at question number 3 here, it says the triangle ABC. There's angle A, that's 52 degrees. A and C, between A and C is 26.2. A and B is 18.8. Find angle A. It doesn't really matter how you draw this triangle, as long as you put these numbers in the correct spot on your triangle, you'll be solving for the same thing as me. You can rotate this triangle however you want, okay? You can flip it, rotate it, doesn't matter. You're still solving for the same thing. What are we all solving for here? We're solving for this side length A. I can't use sine law because I don't have any sides or angles that match up. So I have to use this cosine law method. So what that is when I'm solving for a side length, I need the angle that matches. So that's why I circled that 52 that matches to the angle A. Then we're just going to use the formula, which says take the other side lengths. So this 18.8 square, add it to the 26.2 squared, minus it from 2, multiplied by 18.8, the 26.2, and then what's important at the end is that cos 52. So again, you can type this in all in at once. I don't do that. I solve for the two sides separately. So if you take out your calculators, 18.8 squared plus 26.2 squared is 1039.88. 2 times 18.8 times 26.2 times cos 52 is 606.5. When we subtract them together, we end up with 433.38. We know that that's not our final answer, that we still have to square root it, just like Pythagorean theory, and we end up with 20.8. For our next one here, let's make sure that we've drawn it correctly. ABC, side length A, which is across from angle A, is 9. B, so across from B we have a 7. Across from C we have an 8. Remember, that's how we're going to label our side lengths. It's not, the side lengths are always opposite to the angle. Now let's see what this question wants me to solve for. Find angle A. Cool. So what's important here, I'll circle, is the side length that matches to angle A. So I'll use my formula. Trying to find that angle A. You're going to take your other two sides. You're going to square them and add them up. The one that you subtract at the end here on the numerator side is the one that matches. So the 9. The 9 matches to the A. We're going to take that 2, multiply it by 8 and 7, which are the other two sides. Again, I always solve for the numerator and denominator separately, so I got 32 over 112. You can do the math on your own. If I do the inverse of that, so second function cos, 32 divided by 112, angle A ends up being 73 degrees. You can see how these two questions 3 and 4, we're basically using the same math that I taught you before, only now we're adding an extra step of just drawing the triangles yourselves. And that's what you'll be expected to do. So now going to the end here with a summary of when we can use cosine law. We can use cosine law when you're given two sides and the contained angle. So what that means is you've got this contained angle between these two sides. So what am I asking you to solve for? This other side length. Or when you've got all three sides, 1, 2, 3, and then I can ask you for any angle because it matches up. So that's why this example above, we can see that we have 1, 2, 3, all three side lengths. Or we've got two side lengths and a contained angle. That's how we're going to solve. So that's the summary that's given to you at the bottom here. And that's all we need to know for cosine law.